Students, good morning. Now I am going to continue with the discussion of molecular diffusion in gases. Molecular diffusion in gases. Finally, we arrived at the equation for flux of component A. Na is equal to Na divided by Na plus Nb into dAb into C divided by RT into Z into ln Na divided by Na plus Nb minus Ca2 divided by C, Na divided by Na plus Nb minus Ca1 divided by C. This is the equation what we arrived for steady state molecular diffusion in fluids at rest and in laminar flow. This is the equation for steady state molecular diffusion in fluids at rest and in laminar flow. This is the equation for steady state molecular diffusion in fluids at rest and in laminar flow. Now I am going to rearrange this equation for molecular diffusion in gases. Assume that this gas obeys ideal gas law. Which states that PV is equal to nRT. At a total pressure of 1 atmospheric pressure, Pt into V is equal to nRT. So N by V is equal to Pt divided by R into T. P stands for total pressure, R stands for gas constant, T is the experimental temperature, and N number of moles, V volume of solution in liter. So moles divided by volume of solution in liter is the unit of concentration. Concentration is nothing but number of moles of solute present in volume of solution in liter. So N by V is equal to concentration C. Since this is total pressure, this is called as total concentration. That means Ct is equal to Pt divided by R into T. Ca1 is equal to Pa1 divided by R into T. That means partial pressure. Similarly, Ca2 is equal to Pa2 divided by RT for partial pressure. Clear? Now I am going to use this information with this main equation. Clear? Right. So what about the final equation? Na is equal to molecular diffusion for gases. Na is equal to Na divided by Na plus Nb into dAb. Instead of C, I am going to write Ct. Instead of Ct, I am going to write Pt divided by RT. So dAb into Pt divided by RTZ. Clear? Into ln. Na divided by Na plus Nb minus of what is this? Ca2 by C. Ca2 by C. Just listen. Ca2 by C. Ca2 is equal to Pa2 bar divided by Pt. Similarly, C is nothing but Pt into what is this? C is equal to nothing but C is very Ct. Instead of Ct, I am going to Pt divided by RT. So instead of this one is RT, this is again Pt by RT gets cancelled. So Ca2 by C is equal to Pa2 bar by Pt. Similarly, Ca1 by C is equal to PT. Substitute these two information on this place. Clear? So finally we arrived PA2 bar divided by PT. Similarly NA divided by NA plus NB minus PA1 bar divided by PT. Now establishment of relationship between NA and NB is essential. Establishment of relationship between NA and NB. Now let us have a simple example. Cracking of methane, catalytic cracking of methane. Methane is being cracked on a catalyst surface. Clear? Assume that this is the catalyst. Methane comes to the top surface, CH4. During this catalytic cracking, methane will produce carbon and hydrogen. As per the stoichiometric, this is 2 moles of hydrogen. Listen. Methane is entering into the surface of the catalyst. Formed hydrogen is moved away from the surface of the catalyst. This is one direction, this is opposite direction. This is entering into the surface, methane entering into the surface, hydrogen leaving from the surface. Both are opposite direction. Clear? Next, methane in the reactant side. Reactant side means negative. Hydrogen is positive product, positive side. What about carbon? Carbon is deposited on the surface of the catalyst. You leave it, ignore this one. So methane is the product, methane is the reactant, negative side. Hydrogen is the product, positive side. Methane entering into the surface for cracking process. The formed or produced hydrogen move away from the cracking surface, catalytic surface. Clear? Now I am going to relate the stoichiometric coefficient and rate of reaction. Stoichiometric coefficient, rate of reaction in terms of flux. That means Na divided by minus 1 number of moles of methane being cracked. It is in reactant, hence I put minus sign. NB, B stands for hydrogen. Methane is the notation A, hydrogen is the notation B. Okay. NB, number of moles of hydrogen produced 2. This is its product side. Clear? This is the relationship between rate as well as stoichiometric coefficient in a reaction. Now the relationship between these two are minus 2 Na. Directly substitute this information in this final equation. See, this is the final equation. Substitute Na by Na plus Nb. Clear? Now, if you are substituting this one in this relationship, that means Na divided by Na plus Nb is equal to Na divided by Na minus 2Na. Clear? Nb is equal to minus 2Na. Substitute this. So this relationship between becomes minus 1. Substitute this minus 1 value here and get the final equation. It's up to you. Clear? So what I am going to discuss, what I am discussing in this class is molecular diffusion gases. Already we derived the equation for flux. That means steady state molecular diffusion in fluids at rest and laminar flow. This is the final equation. From this equation, I am going to bring the equation for molecular diffusion in gases. Assume that gas obeys ideal gas law. That means PV is equal to nRT or PT is equal to nRT. N by V, number of moles in volume of solution in liter. That means concentration C. So C is PT by RT. This is total pressure, hence it is CT. Arrange these information in orderly. Clear? This is the final equation. Once you are substituting this information here, this is the final equation. And establishment of relationship between Na and Nb is essential. For example, let us consider catalytic cracking of methane. Methane is being cracked on the catalyst surface. During cracking process, methane enters into the surface of the catalyst. The produced hydrogen moves away from the catalyst. Both are in different direction. And establish the relationship between rate and the stoichiometric coefficient. This is the relationship. This is flux, this is stoichiometric coefficient. 1 moles of methane, this is in reactant side, hence I put minus. 2 moles of hydrogen. This is in product side, as I put plus symbol. So Nb is equal to minus 2Na. Substitute this relationship with this equation. So Na plus Nb is equal to Na divided by Na minus 2Na. So this will be minus 1. Substitute this Na Nb relationship with this equation, get the final equation. Thank you.